Hello everyone, this is Direwolf20 and welcome to part 2 of the ComputerCraft checkers tutorial thing. So basically, want to get you guys familiar with how the ComputerCraft checkers code that I wrote works. So far, looking pretty good. Got a bunch of things left to cover. Last episode, if you didn't see it, talked about how the board is drawn on the screen and the basics of how I store the data about what pieces where, both on the monitor and for the turtles in the real world, or the Minecraft real world, if you will. So definitely check out that if you haven't yet. Just like that episode, this one will be almost exclusively ComputerCraft code, so if you're not interested in that, this is probably not the video for you. But if you're really hoping to learn how this checkers program works, then I hope you'll stay and watch. Alright guys, so without further ado, let's talk about all the code that makes these turtles move around and how to determine whether or not where they're moving is valid. Now for the main attraction, the wait player function. This is the function that once everything has been lined up and set up, it's waiting for the player to do something. So whenever a player clicks on something, it's going to go ahead and process those clicks and handle it. So the first thing we do is create a variable called valid and set it to false. And we call the getClick function, which is just up here. And basically what that does is it does that pull event monitor touch event, and it returns the XY of wherever the player clicked. So imagine the player clicked anywhere on this black square, like here for example. Okay, we can see here that it gets that, and it does if button.checkXY, then return true end. What that does is it checks if I clicked on a button somewhere. So there's only two buttons I'm using on this, new game and quit. So that's that button API, which I've explained and used in the past, so I'm not going to go into that too much. But that first line there is just checking. The first thing it wants to see is, did you click on a button? If not, then don't do anything. But if you did, then get out of this function and run whatever that button tells you to do. All right. But if you didn't click on a button, I'm going to assume you clicked on the board somewhere. Okay, and what you do is get the AB position of wherever the XY is. So remember I showed you that before. I said, anywhere you click on the square, it can find the AB coordinates of the square. So if I clicked over here, it would be X1, Y4, or A1, B4, if you will. So 1, 4. So that's what it gets first, is it checks the AB coordinates. Then it checks if you clicked somewhere outside the board. So it says, hey, if you clicked to the left or on the bottom or somewhere outside the board, then just come back and say, no, that's not good. I don't want you doing that. Return false. Get out of this. You're doing something wrong. Then it goes ahead and says, hey, if that get piece function a comma b, all right. If there's not a piece there, or if there is a piece there, so if it's not nil, so that means if there's at least some kind of color, if it's not a blank square, and it calls the myTurn function, okay, of the color in that square. Remember, getPiece returns the color of a piece. Okay, I'll explain myTurn in a second, but it just checks to see if it's that player's turn. So it's keeping track of whose turn it is, and it knows what color you clicked on because it used the getPiece function. So it says, hey, is it that guy's turn? Make sure that it's Pink's turn and I didn't click on a gray piece to try and move it. If if that's the case, if it is my turn and I didn't click on an empty square, then I'm going to go ahead and write out a message as to where I clicked up here. So you might have seen the messages showing up here of the coordinates. That's where I clicked. All right. Then it runs the getClick function again. And what that does is it gets a new XY of where I clicked. So let's say I clicked on this piece and it's Pink's turn. It says, all right, there's a piece there. It's Pink's turn. We're good. Let's continue along and say, go ahead and get another click. That's the function that waits for me to click on where I'm going to. And once it gets that, it stores that in another variable called A2 and B2. So A and B is where I'm at, and A2, B2 is where I'm moving to. Works pretty well, I thought. And then it goes ahead and writes the A2, B2 up on the top right in green. Then it runs a couple complicated functions called try-move and try-jump and switch-turn. And we're going to go into all of them now. So try move, let's give that a shot, okay? We're going to come down here and check out try move. First off, here's my turn. Just says, if current turn is colors.pink, then, it checks if it's either pink or blue. Now, this is an important thing to note. Remember, when you get kinged, it turns your piece from pink to blue. And when you get kinged as a gray piece, it turns it from gray to white. So it just checks both of those. It says, if it's currently Pink's turn, and the one you clicked on was either pink or blue, then you're good to go. So that's how that works. Is king basically just checks to see if the current piece is a king, which I haven't used yet. And then we want to go down to the try move function. So this is the first thing it tries to do is, it goes ahead and says, I want you to try and move. Let's go over how that function works, because let's assume that I clicked here to here. And that's the AB and A2B2 gets sent down to the try move function. So the first thing we check is we get the absolute value of A minus A2 and the absolute value of B minus B2. Anybody who's not deep into math may not know that absolute value means that if it's a negative number, just make it a positive. Okay. So what's happening here is we're just checking basically to see if this is exactly one square piece in either one of the four directions, because it says you have to move it, up one and over one, or up one and left one, which might be a negative number, but that's why we get the absolute value, down one and over one, and down one and over one. So it just checks to see, hey, if you're trying to move this piece, it can only move, here, 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 or here. That's what that line is doing. Okay, it's comparing the difference between the A and B coordinates, and it's making sure that they're both absolute value of 1. Now, if either one of those are not 1, and that's what the tilde equals mean. It says if the A coordinate is not a difference of 1 or the B coordinate is not a difference of 1, then return false. Now you might remember in my wait player function that I'm using this inside an if. So I'm saying if try move is equal to false, then try and jump. Because what I'm doing here is I'm saying, well, look, I tried to move and it looks like, this number is not a difference of 1. So we better check to see if maybe it's a jump that he's trying to do. Because if I'm trying to jump, that 1-1 thing would not work out too well. So that's what I'm doing there, basically. Trying to move, false, then try and jump. But there's some more other things we have to check in the try move function before we try and jump. Okay? The other one is called the AnyJumps function, and I'm going to get to that in a minute, but you guys remember that I had the rule set up that if you can jump, you must. Well, the AnyJumps function checks to see if any piece on the board that's equal to the current turn's color can jump. I'll get to that in a minute. Finally, I run the isValidMove function, and I send that the AB, A2, B2. So during the try move function, I finally call isValidMove. And this is a little bit more in-depth look to make sure that it's a proper move that I'm doing. So we go ahead and get the current piece that's trying to be moved. And then we get the piece in the position of where it's moving to. So that's one of the first checks. We want to make sure that it's, a blank space. If it's not a blank space, then we're like, hold on a second. You're trying to move a piece onto a piece, and there's already a piece there. You're crazy. So one of the first things it checks when we're checking for a valid move is if, we move from here to here, and there's already a piece here, it says no, you can't do that. Returns false and sends it back to that original function. Then we want to check and go ahead and see if it's the pink color and the B is less than the B2, return false. What that is if you're pink and you're trying to move in this direction, you're going to get a false return. It's going to say you can't move backwards when you're pink. And it does the same thing for gray, except in the greater than position. It says you can't move this way when you're a gray piece. Okay? But note it's only checking for pink and gray. Blue and white pieces, it doesn't care about. So it just says, if you're pink and gray, I care what direction you're moving. Blue and white can move any direction they want. All right? So the try move function checks a couple things. It tries to make sure that you're moving in one direction or one block in every direction. It makes sure that there aren't any jumps out there already. And then it goes ahead and checks if it's a valid move. And if it is, then it runs the move piece function and the switch turn function. Okay, and what that does is it calls switch turn, and it switches it from red's turn to black turn. You guys already saw that, but you haven't seen move piece yet. Now, if for any reason it determines that you're not allowed to move that piece, okay, one of those reasons, of course, being that you tried, instead of going from 1 and 1 position away, you went 2 and 2 positions away. Well, then it's going to say, all right, I couldn't move it, so let's see if this is a valid jump of some kind. Maybe he's trying to do a jump, and we're going to let him do that. So that's why we call the try jump function. So if we couldn't move it, then we're going to try and jump it. And if that's the case, then we're good to go. So try jump, instead of checking to see if it's 1 and 1 pieces away, it has to make sure that it's 2 and 2 pieces, because a piece can only jump here, 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 or here. Okay, so those are the pieces, and you'll note that they're all exactly 2 pieces away on either side, both on the x and y coordinates or the a and b coordinates. Okay, so first off, we're going to say, hey, if you're trying to jump, you better be 2 pieces away from where you're starting. Otherwise, you're no good. Return false. We're done with this. All right. Then, if after that passes the test, it goes ahead and does, is this a valid jump? AB, A2, B2. Okay, and the isValidJump function is up here. It's another one of those I have to dig a little deeper times. All right, so first off, again, it's checking to see if you're not clicking outside the board. It wants to make sure that you're not outside the board with these first 2 lines. Okay, then again, it checks that is it the 2 pieces away thing. It's kind of like a double check because we use isValidJump elsewhere, so we have to run these checks again. Then we get the a temp color variable, and we get the piece in the AB coordinate of what's being moved. So remember, AB is the piece that's starting the move. That's the pink one. Then it takes A plus A2 and divides by 2, and B plus B2 and divides by 2. Why are we doing that? Well, let's say that you're in position 1, 1, and you're jumping to position 3, 3. Okay? 1 plus 3 is 4, and 1 plus 3 is 4, so that's 4, 4. Divide each of those by 2, and you get 2, 2. So basically what's happening here is we're getting the position in the middle of the ones that are being jumped because we want to make sure it's not the same color. So it calls that jump color, and it says, what's the color of the piece that's being jumped? Okay. Then we run that isValidMove function from before. And basically, remember, isValidMove to make sure you weren't jumping onto a piece that already existed. So we want to make sure there's not a piece in the spot that's already there. So we have to make sure that it's valid to move to the new position. Then it says if the jump color is nil, return false. Well, remember, if we're doing a jump, there better be something there that's getting jumped. So if there is nothing there, it's going to return false. So this is just another check to make sure that you're not trying to cheat and do something you're not supposed to do. Then it checks and says, hey, if it's a gray or a white piece, then if the color that's being jumped is pink, or is not pink and not blue, then return false. And it does the alternate for the other colors. So basically this is just saying make sure that the color being jumped isn't your own. You can't jump your own pieces, as far as I know in checkers. Now there's plenty of house rules in checkers, so I better jump in here and tell you guys I'm aware that there's some other rules that you guys might play with, but I just kind of went for like the basic rules. If you want to add in some other conditionals, be my guest. You're more than welcome to. So once it checks all that stuff and it doesn't return false anywhere else, it gets to the very bottom of the function and it returns true. If it got past all these different if conditionals and none of them returned false, it's going to say, all right, this guy must be a good valid jump, so let's return true. Then, since it returned true, we got to do this stuff. So the first line here sends a message to the turtle. Remember that a plus a2 divided by 2 thing? So it finds the turtle, the getTurtle function, in the piece that's being jumped. And it says, hey, send a message called goOut. That's the program that sends the turtle to its out position, which might be over here, or it might be over here, one of these 2, rows, something like this. So remember, all the turtles have out positions that look like that, so it just sends it to that out position, okay? So the first thing it does, once it determines that it's properly jumping something, is it goes ahead and does that. Then it runs that update score function. It gets the color of the piece that is being jumped. So again, we're using that a plus a2 divided by 2, b plus b2 divided by 2, gets the color of that piece that's being jumped, and updates the score by subtracting 1 from it. Okay? Then it runs the setPiece function, and it says, that piece that got jumped? Well, it's not there anymore, so set it to nil. And do the same thing for the turtle. Remember the turtle that got jumped? It's no longer on the board, so set it to nil. So that way it says this board position that used to have a black checker piece, and it used to be turtle ID 16, all right, go ahead and set the color to blank so that there's no checker piece there anymore, and set the ID to blank so that there's no turtle there anymore. Then we run the movePiece function, which again I mentioned a little bit ago, but I haven't shown you guys just yet. Then it goes ahead and checks if you can double jump, and it takes the new position, so this guy jumped up here. And taking the new position, it runs the canDouble function. And for as long as it can double, it goes ahead and tells you that you can double jump and gets a click, and then it tries to jump there. Okay? And if it succeeds in jumping, good. It's going to continue along. If it fails to jump, then it's going to force you to try again, and it's going to keep trying until there's no more double jumps. That's why we're in a while loop. We just keep checking to see if you can double jump. Cool. All right, return true at the end of that, and return false if you were the is valid jump. Okay. If it is a valid jump, then we return true at the end. But if we get outside that loop for some reason, then we have to return false, saying something didn't work. We didn't get out of there with a valid jump going on. Now, can double is pretty straightforward. It takes the position that you're currently in. So we've jumped, and now we want to see, is there any valid double jump? Is there anywhere else we can jump to? Okay, and the way that works is it says, hey, go ahead and give a +2 to the A and B. And if that's a valid jump, remember I told you we use is valid jump elsewhere? Well, we're using it here. We're saying, hey, we're going to assume you're here, and then we're going to check, hey, is this a valid jump? If so, return true. If not, check over here. Is this a valid jump? If so, return true. Otherwise, check if this is a valid jump, or check if this is a valid jump. And remember, is valid uses is valid move, so that checks to make sure that the right color can move. Okay, so that's how that works. And basically, it sets double equal to true. So double starts off as false, and if any of these turn out to be true, then it sets double equal to true and returns double. Cool. Now that I've covered can double, I can show you guys how any jumps works, because you might have noticed in one of my first videos on this, I didn't know about that you have to jump if you can rule, and I added it in after the fact. So I said, hey, I can just use that can double jump thing. So now can double is kind of the wrong kind of a name, but I just stuck with it. Probably a little bit lazy on my part. But basically I say, go through the entire board, okay, and if any of these pieces can jump, remember it just checks, it goes through and it says, hey, can this guy jump anywhere? Can this guy jump anywhere? Can this guy jump anywhere? It just checks through all of them, and it's that player's turn, so it says, all right, is it the gray's turn and he can jump somewhere? Then go ahead and say jump is true. And that's used in the wait player function. It basically says, if you're trying to move and you're trying to, it's in the, I think it's in is valid move, that's right. So try move, it says, hey, if there's any jumps and you're trying to move, return false, he's supposed to jump. And the rest of the program isn't that much more to it. So we've already covered how we check if they're valid moves or jumps. We've checked a lot of other things. The message program just writes out random messages, such as, you have to jump, or, a couple of the messages went out through. Update score, you just tell it what color you want to update the score of. It says if it's blue or pink, then subtract 1 from the red's team. So if red got jumped, red score is -1. Otherwise, it's probably black who got jumped, because there's only 2 teams, right? So, we can check if it's red. If it's not red, then it must be black. Is red as a function used once or twice? It just says, hey, if this is the red team, return true. Otherwise, return false. And it checks both for pink and blue on the colors. And then we get to move piece, which I told you guys I would cover just in a bit. Move piece says, get the color of the piece that's trying to be moved. So remember, A and B is the position that you're currently at, and A2, B2 is the position that you're going to. Okay. In order to move a piece there, it says, hey, if temp color is equal to colors.pink, and B2 is 1, so it says, hey, if you're a pink piece and you're moving up to the first row here, then you're getting kinged, and it changes the color to blue. And it does the same thing for gray, but at the Y level 8. So if you're a gray piece and you moved all the way down and you just moved on to position 8, then change your color to white. Neat. Then it does the turtle move function, A, B, A2, B2. Haven't covered turtle move yet, but long story short, that's moving the turtle. All right. It does that set piece position, so it sets A2, B2 equal to the temp color. So if you're pink, it sets the position here to be pink. It says, all right, this spot now has a pink piece. And then the very next line is it sets the original AB position to empty. So it says, all right, you're here. When you click here, it makes this a pink piece, and it makes this a null piece, or nil. And then it redraws the board and the pieces. So what that does is it just says, all right, refresh all the pieces, redraw all the board, make sure everything's good and solid. We're good to go. Why do I redraw the board every time? Well, if I didn't redraw the board, draw pieces would put an X, here, but it doesn't put spaces. So by redrawing the board, it makes sure that it removes all the pieces first. So real quick, before you even see it, it clears the board and then redraws all the pieces every time you do a move. Now, turtle move is a little complicated. I'm not going to go into too much of a detail, but basically, well, it's not that complicated, really. It gets the color of the piece that's being moved, and then it gets the turtle ID of the turtle that's being moved. So remember the original position of the one being moved, that's this guy. He's getting moved there. And basically says, if it's red's turn, and, it checks the direction it's moving in. It compares the A and A2 coordinates and the B and B2 to figure out if this guy's moving here, or if he's moving here, or here, or here. Okay? And it says, based on those, if it's red, okay, you have to move forward and to the right. Okay? So red, if he's moving up here, has to move forward and to the right. So it just sends a command to the turtle saying move forward and then move to the right. However, if it's a black piece that's moving here, black pieces are usually facing this way down, so they actually have to move back and to the right. So that's why it says if it's red, then move forward right. Otherwise, move back and to the left. It's back and to the left. Okay, and then here's forward left or back right. So if it's red and he's facing that way, it's forward and to the left. If he's black and he's facing this direction, it's move backwards and to the right. Cool? So that's basically what move turtle does, is it sends the command to the turtle. The turtles are dumb. They don't know anything about the board. They're just told, hey, move forwards and then move over to the right one. And that's all they get told. And they just do as they're told. Okay? Then it goes ahead and, it figures out the message that it's sending. Okay, there's two functions it gets. One is for if you're just moving, and all that does is it moves it flat on the board. You guys might have noticed that when the turtles move, if they're just moving across the board, they don't move up. But if they're jumping, they move up, then move, then come back down. Well, it basically says, hey, if you're just doing a normal move, if the differences are 1, then just send the message forward right. Otherwise, append the letter J to the beginning of the message, which becomes JFR, and that tells it to do the jump forward right function. And then in the end, it just prints out what message it's setting. It sends it over the RedNet to the getTurtle of the AB coordinate. So it runs that getTurtle function. It says, hey, I'm moving this piece. What ID is the turtle in that position? Get it, and then send it the message I just wrote. JBR or just BL, something along those lines. It sends it, and it waits for a message to come back saying it was successful, because I don't want people doing a bunch of moves while turtles are all over the board. And usually the turtles are done moving within a few seconds, so I told it, time out after 10 seconds, make sure that something did move. Then we do that set turtle command to change the position, just like we changed the position of the colors on the board. Okay, we go ahead and say, hey, now, AB is, there's no ID of a turtle there, and the position we move to, this is the ID. It grabs that temp turtle ID again. Cool. Function quit, real simple, is it sends everybody out of the board, so it tells all the turtles get off the board. That's what that test out program does. It resets the background colors, it clears the screen, and it does a pull event on monitor touch. This is the reason that when you run the quit program, the computer is blank, and it just waits for somebody to click on the computer. So whenever you click the quit button down here, it sets the monitor to blank and waits for you to click it. And as soon as you click anywhere, that's when it loads up again. That's how this works. Then it runs drawboard. It creates the new game and quit buttons here using the button API, new game and quit buttons. Then it sets the text color and redraws the screen. And remember, the button API screen is what actually draws the buttons. And then we have the new game function. Sets the player's turns. It sets how many pieces they have remaining, and then it does the draw board, load board, new game, draw pieces, display turn, and then it creates those buttons again, just in case you're creating a new game here. Cool. So those are all the function in checkers. Okay, that's really all there is to it. Hopefully I explained it well enough. I know it was very heavy duty on computer stuff, but that's what you guys wanted. You wanted a tutorial of how the checkers program worked, so I did my best. Hope you liked it. When the program first loads up, it runs quit. Okay, and the reason for that, and then it says while true, do wait player. So quit, remember, okay, goes ahead and clears the screen and waits for you to click on it, and then once it's done, it goes ahead and runs the following things here. And remember, the new game button here, according to the button API, runs the new function. So what it does is it draws a board and then waits for somebody to click new before it sets up all the pieces and all that stuff. Cool. And then it just runs while true wait player. So that wait player function is really the meat and potatoes of this whole program. It sits there and says, all right, I'm waiting for the player to do something. And when the player does something, it runs a bunch of checks to make sure that everything that the player did was valid. And if it was valid, it issues all the functions from there. So really the simpleness of this program is it just consistently runs wait player. And there we go. I just ran checkers. It's currently waiting for somebody to click anywhere on the board. Once it does, it draws the board and draws the buttons, and it waits for somebody to click the new game button. Once that happens, it runs all the board command, fills in all the variables, and does everything for you. Now, the only thing I haven't shown you yet is the turtle programs. So I'm going to run edit the turtle bot, or checker bot is what I named it. And this guy is pretty straightforward. He just opens up on the right a RedNet. Activates his modem, and then he's got some functions. Up and down, forward right says move forward, turn right, move forward, turn left. So the forward right command says move forward, turn right, move forward, turn left. So that's the function called FR, and that coordinates with the function that's being sent from the master computer. Okay, and we've got similar ones, forward left, back right, and back left. And then we have the go home, which runs the go home program, the go out, which runs the go out program, and then we have this guy, wait message. Okay, what it does is it waits for a message from the master computer, and if it gets sent FR, it runs the FR program function. If it gets sent BR, it runs the BR program. Otherwise, it goes here and it says if the message is to jump forward right, it moves up, so it goes up one, it goes forward right, and then it lands here. So it runs forward right twice, and then it moves back down. So you can see the down program here. So this is the part where I once said, I think on one of my videos, that they aren't super intelligent about making sure that they were moving correctly, and that was just because I was being a little sloppy in my code. I could have cleaned up this code a little bit to validate that it moved properly before it finished its program. So that's something, on my to-do list once I want to clean it up. Finally, it just says, based on what message I get from the master computer, I'm going to run that program. We're good to go. So let's go ahead and let this happen. And while true, do wait message. So all this thing does is it sits here and runs this wait message function over and over. And whenever it receives a message, it's going to go ahead and execute the instructions it was given. Real simple. Cool? And with that, guys, I think I've pretty much covered everything within how this program works. I told you how the checkers program works. I told you how the turtles are instructed to move around. And I've told them pretty much everything. I didn't explain button, but, I've got and explained the button API in the past in videos, and it's up there in Pastebin. So hopefully you guys are good with that. Leave some comments on the video. Let me know how you liked it. Now, of course, I made it very clear that this was a fully explaining ComputerCraft and explaining the programming and all that stuff of how the checkers program works. So I hope nobody sat through this whole video and then got upset that I was, spending a whole episode on talking about programming, because that's boring. So this is what this was about. So leave some comments. Let me know how I did explaining it. I'm trying to be a good explainer on this stuff, but it's a little tricky to explain code. It's a little dry, and I apologize for it being a little boring and dry, but, nothing I can do about that. It's just the way it is. It's the nature of the beast, if you will. So hope you guys enjoyed it. Leave me some comments. Leave me some feedback on if you liked this. If you want me to do something like this in the future whenever I write complicated ComputerCraft code. If you want me to spend a whole episode or just a whole little bit of time talking about how things work. Yeah, let me know. So looking forward to reading those comments. But for now, Direwolf20 signing off on the checkers tutorial. Hope you enjoyed it, and take it easy.